Last class we have discussed about the warp knitting technology, its definition, various elements of warp knitting, their role, and various parts of the warp knitting machines, and the two types of warp knitting machines, Russell's and Tricoordinating warp knitting machines, and also we have discussed the comparison of these two type of machines. Now we shall proceed further. Our next topic of discussion is mechanism of loop formation and some aspect of warp knitting. So outcomes of these sessions are students will be able to explain principle of warp knitting. Students will be able to explain functions of various warp knitting elements. Students will be able to explain the mechanism of loop formation of warp knitting, able to draw structure of warp knitting fabric. Students will be able to calculate production of warp knitting and derive tightness factor of warp knitted fabric. So principle of loop formation in warp knitting. So needle bar movement. You know the needle is most important knitting element in both warp knitting and wave knitting. So needles in the warp knitting machines are placed on the needle bar. So all the needles which are situated on the needle bar, they will move all together with the movement of the needle bar. So that's why the movement of the needle bar is very important to understand, and how this needle bar movement is actually performing the loop formation for the preparation of the warp knitted structure. So the needle bar is lifted up and lower down for the purpose of loop formation. Okay, so that means the needle bar is having some up and down movement in vertical direction. During the upward movement, the old loop is clear. As you know, during the upward movement, the old loop is clear and the needle catches the yarn wrapped around it by the guide. So the function of the guide is another element, that is the wrapping or lapping of the yarn over the needle or the hook of the needle, and forms the new loop during the downward movement. So the needle will catch the new thread which is wrapped by the guide, and the needle will draw the thread downward for the formation of new loop. Such movement is imparted on the needle bar by means of cam or eccentric fitted on a shaft called eccentric shaft. So this up and down movement has been controlled or has been governed by either a cam or an eccentric which is fitted in a shaft which is called eccentric shaft. The shaft extends to the full width of the machine, and the cam is located outside the machine, generally at a driving side. Okay, one side of the machine there will be one motor which is driving the machine. So from the driving side, the drive is given to the shaft, eccentric shaft, which is extended to the full length or the full width of the machine. The cam is kept in an enclosed oil bath in order to have less vibration. Okay, as the warp knitting process is a very high speed process, so during high speed rotation of the cam, there will be rigorous friction, and due to the friction there will be the high vibration and noise. So to reduce the friction and vibration, the cam is kept enclosed in a oil bath. Okay, cam is basically immersed in a oil bath for reducing the vibration and sound, heat, etc. for the better life of the cam and the machine. Now next part or next element of the warp knitting machine is guide bar. Okay, so guide bars, there are many guides, as many as number of guides will be there, as many as number of needles will be there on the needle bar. So all the guides are situated on a guide bar. Here you can see in this diagram, okay, if these are the needles, they are the bearded needles. Okay, the needles are vertically up in this way, and this is the guide bar. Okay, and these are the guides. Okay, guides are having some holes through which the threading has been done. So each and every guide at least threaded with a thread or warp yarn. Okay, so these are the guides. These finger-like elements are guide. So all guides are situated on the guide bar. In order to feed the yarn to the needle for loop formation as well as to connect the adjacent wales, the guide of a guide bar are required to execute a compound lapping movement. So a compound lapping movement is there in the guide. Okay, compound movement. So that movement is required for lapping the yarn across the hook of the needle as well as for connecting the neighboring loop. Okay, for the preparation of a chain of loops in the widthwise direction of the fabric, so which is also called the interconnection of the loop. That interconnection of the loops is actually made by the guides which are having a compound movement. This compound lapping movement is composed of two separately derived motions. There are two types of motions in the guide bar. One is swinging and another is shogging. So now we need to understand the swinging and the shogging movement of the guide bar. So combination of these two movements is called the compound lapping movement. A swinging motion and a shogging motion act at right angle to each other in order to form overlap and underlap. So these two motions, swinging and shogging, they will act at 90 degree to each other. Okay, so due to these two movements, there will be the two phenomena, overlap and underlap. Okay, overlap is a phenomena when the yarn is lapped over the hook of the needle. Okay, that is called overlap. And when the yarn is lapped behind the needle, behind the hook of the needle, then the motion is called underlap. Okay, when overlap will occur, the needle will be able to catch the thread. Okay, or feeding is possible. When underlap will occur, then feeding is not possible. The needle cannot be able to catch the thread for the loop formation. Okay, the swinging motion of the guide takes place either from the front of the needle to the back or from the back of the needle to the front. So swinging motion, you can see this arrow. Okay, so the guide bar will swing in this way. Okay, from the front side to the back side of the needle. Okay, either from the back side to front side of the needle or from the front side to the back side of the needle. Okay, so this swinging motion when occurs, the guide bar will travel across the place which is there in between the two adjacent needle. Okay, there is a gap between the two needles, so through this gap the guide will move from the front and back side of the needle or from the back side to the front side of the needle. It is in arc and it occurs between the adjacent needles. The two swinging movement produce the two side limbs when the combined with the overlap shock. Okay, so these side movement, the swinging movement will produce side limbs of the loop. If you can remember the limbs of the loop in case of wave knitted loop, okay, you can see there will be, you can remember there will be the head or crown and there will be the limbs of the loop. So in this way the limbs are there in the wave knitted structure also. Those limbs are produced due to this swinging movement. Okay, when there will be the overlap shock. Now come to the shogging movement. Okay, the shogging movement of the guide bar is the lateral movement of the guides which occurs parallel to the needle bar. So come to this figure, the shogging movement, you can see the arrow. That means the shogging will occur in this direction. Okay, in the horizontal direction. Okay, the guide bar will shog from left to right or right to left. That's what is written here. The shogging movement of the guide bar is at the lateral motion of the guide which occur parallel to the needle bar. So needle bar is there in the horizontal direction and the movement of the guide bar will be parallel to the needle bar. The shogging movement of the guides may be from the left to right or from the right to left. Moreover, the extent of shog may vary from cycle to cycle or from bar to bar. So extent of shogging means how much distance the guide bar will travel from right to left or left to right. That depends on cycle to cycle, depending on the design of the fabric or design of the structure, and that also depend on bar to bar. If the machine is having more than one number of bar, 2 bar, 3 bar, 4 bar or 6 bar machine, so maybe the bar to bar, the amount of shog may be different depending upon the design requirement. The shogging of the guide bar may occur either in the front of the needle or at the back of the needle and accordingly produces overlap and underlap. The front side of the needle is actually the side where the hook is present. Okay, you can see all the needles are having the hooks in a same direction. So that direction is called front direction, where the hook side, you can see the hooks are present in the needle. Okay, so the shogging of the guide bar may occur either in the front side of the needle, that means in which side the hooks are present, or at the back side of the needle where the hooks are not there, and accordingly produce overlap. When the shogging has been done at the front side of the needle, then the lapping of the yarn over the hook is possible. Okay, then the hook of the needle can be able to catch the thread or the feed the thread for the loop formation. So that will produce overlap. And if the shogging is done at the back side of the needle, then underlap will produce. Then the hook of the needle cannot be able to catch the thread. Okay, then underlap will produce. No loop formation occurs. The shogging movement can occur when the guides have swung clear to the needle heads on the back or front of the machine. Okay, so already I have discussed the occurrence, timing, direction and extent of each shog is separately controlled for each guide bar by its pattern chain link or pattern wheel attached to the horizontal pattern shaft driven from the main camshaft. Okay, so there is a main camshaft of the machine. From the main camshaft, a drive is given to the pattern shaft. Okay, on the pattern shaft, there will be either pattern wheel or pattern chain link. So this pattern wheel or pattern chain link, they will give drive to each and every guide bar separately for the shogging movement. And as a result, each and every guide bar is having a particular amount of shogging for a knitting cycle. Okay, so that has been decided by the design which we want to produce by the machine. Okay, so the mechanism and the motion which is given by the pattern chain links and pattern wheel is very important to understand for getting a particular or typical design of the warp knitted structure. The combined effect of the underlap and overlap is the lapping of the yarn around the needle. Okay, so if there will be the overlap and combination of underlap, then lapping will occur. Lapping or wrapping of the yarn over the hook of the needle will occur. Depending upon the relative direction of the underlap and overlap, there are two types of lap, closed lap or open lap. So depending upon the direction of underlap and overlap, there are two types of lap. Either there will be closed lap when the loop which is produced that will be closed or crossed, or open lap when the loop will be open. So that can be understood from this figure. So this is the structure of a closed lap where this loop has been closed, or the open lap when the loop is open. The closed lap is produced when an underlap follows in the opposite direction of the overlap and thus lap the thread around the both sides of the needle. Okay, so in this situation, the closed lap will produce, okay, and closed lap will give you a tighter construction of the fabric. An open lap is produced either when the underlap is in the same direction as the overlap, or it is omitted so that the next overlap commences from the space where the previous overlap finished. So this is the condition of open lap. Okay, so in case of open lap, the very open, or you can say less compact structure has been produced. In closed lap produce heavier, compact and less extensible fabric than the open lap structure. So that you can imagine, when a loop has been closed, that means crossed, okay, then more tighter fabric can be produced. The tighter fabric will be compact, heavier and less extensible. Whereas in case of open lap, when the loop will be open, then the structure will be very loose, okay, less heavier and less compact and highly extendable. These are the notation, symbolic notation of the closed lap and open lap. Okay, so these notations you can see in case of closed loop, the dots are the needles and how the needles are creating the closed lap. So this is the symbolic notation. In case of open lap, the loops are not closed, actually they are made open. So these are the symbolic notation for the representation of the closed lap and open lap. Now there are 5 conditions, okay, of the overlap and underlap by which closed lap, open laps are produced. When an overlap is followed by an underlap in the opposite direction, then closed lap will be produced. Okay, when overlap followed by an underlap in the same direction, then open lap will be produced. That means at first overlapping has been done by the guide bar over the needle, and then in the next cycle underlap has been done in the opposite direction. Okay, then the closed lap will be produced. But if the overlap is followed by underlap in the same direction, then the open lap will be produced, because the loop cannot be then closed. Only overlap and no underlap. If only overlap is produced for successive knitting cycle, then that will also produce open lap. And only underlap, no overlap. If no overlap has been done, then no loop formation occur, because the needles will not be able to catch the thread. No feeding will be done. So then there will be laying in. The yarn will lay in the structure. Neither overlap, no underlap. If there is no movement of the guide bar, okay, during the successive knitting cycle, then there will be the mislapping. Okay, so that may be considered as the structural defect. So in the last 2 cases, overlapping of another guide bar is required to hold them into the structure. Now in case of tricord knitting machine, okay, tricord machines are generally having bearded needles. So knitting cycle has been shown here. Okay, various steps of the knitting in a tricord knitting machine I shall discuss. For one guide bar machines, one guide bar has been considered for making the diagram, because this is a simple case. But in case of the actual commercial tricord knitting machine, there may be 2 or more than 2 guide bars available. The needles are, in case of situation A, you can see the needles are in the rest position at 2/3 of their full height from the knockover. Okay, now at present this needle is at the height of the 2/3 height positions of its knockover position, and their beards are facing towards the back of the machines. Now the beard, this is the hook or beard, that is facing towards the back of the machine. That means the left side is the back of the machine, and the right side is the front of the machine here in this diagram. The pressure is withdrawn. The pressure which is used to press the hook to close the hook, that has been withdrawn. So hook is now open, and the guides are at the front of the machine with the sinkers forward holding the old overlap in their throats, so that they are maintained at the correct height. Now you can see the guides. This is the guide. Okay, the guide is at the frontmost position. Okay, in the front position, because the guide is in the front side of the machine. So guide is having some compound motion. Either it is having swinging motion from front to back or back to front, or shrugging motion from left to right or right to left. Okay, now at this moment the guide bar is at the front of the machine, with the sinkers forward holding the old overlap in their throats so that they are maintained at the correct height. Okay, now this is the sinker. Sinker is its forwardmost position, which is holding the old loop. Okay, because holding of the old loop is required when the needle is having some upward movement. Okay, and it is also maintaining the correct height of the loop formation and knitting. After swinging in the, now come to the B, and the next step B. After swinging through the needle to the bearded side, now swinging has been done. The swinging of the guide bar has been done. Now from the front side to the back side. Okay, the guide bar is traversed from the front to back, as well as it is having some swinging motion through the needle to the bearded side. Okay, swinging has been done to the beard side. The guides are overlapped across the beard, usually by one needle space in opposite direction. Okay, now the swinging done. Swinging means overlapping has been done in the hook side of the needle by the guide bar. Now this is showing the swinging motion. Now in the step C here, in this case, as the guides swing to the front. Now guide is swinging to the front side of the machine. The needle rise to their full length so that the newly formed overlap slip off the beard into the stem above the old overlap. Now this beard, this bearded needle, that is achieve the highest height. Okay, so that's why the thread which was left over the beard, okay, that is now slip off the beard into the stem above the old overlap. Okay, that is, you can see. Okay, now it is slip over. The needle bar, now come to the D, position D. The needle bar descends so that the open beard cover the new overlap. Now there will be the descending of the needle bar. So that means the needle bar is now moving downward direction. Okay, which will cover the new overlap. Okay, that means that will catch the slipped over thread. Okay, here the hook is catching the thread. There is a slight pause whilst the pressure advances and close the beard. Now the pressure advances and come forward to close the beard so that the hook is closed and the thread will be there inside the hook. Okay, now in step E, as the sinker moves backward, now the sinker starts to move backward. The upward curve of the belly presses the old overlaps onto the closed beard. Okay, the pressure is withdrawn. Now, as soon as the sinker is moving backward and needle is going down, okay, needle is approaching for knocking over direction. Okay, the pressure is getting some backward direction for opening the hook. Now, in the step F directly, the needle continue descending movement and the old loop is cast off. The old loop is cast off. You can see here the casting off or the knocking over of the loop has been done. The needle is at its downmost position. The sinker now move forward to hold down the fabric loop and push them away from the ascending needle, which are rising to the rest position. Now the sinker again try to move forward direction, which will catch the newly formed loop on its throat, and also the sinker will push the fabric in the takedown direction. Okay, the length of a single loop or stitch length, amount of movement in the takedown direction has been pushed by the sinker, so that the takedown of the fabric has been assisted. So in this way, one can describe the loop formation by a tricoordinating machine using a bearded needle. Now you have to study or go through the loop formation mechanism of a latch needle in case of rational knitting machine. Okay, that is your task. You can have these informations or mechanism of loop formation from any textbook. You just go through that, and I think you will be able to understand the loop formation. The basic, the steps and mechanism will be same, but the knitting elements will be different. Now come to the some aspect of warp knitting machines. Here I shall discuss some structural parameters and some aspect of calculations of warp knitting. So course spacing C, that is equal to 1 by course per inch, similar like the wave knitted structure. Well spacing 1 by WPI wells per inch. Loop length L in the warp knitted structure is also proportional to the course and the well spacing. Okay, like the wave knitting. So 1 by course per inch into L, or 1 by course per inch equal to constant into L, or L into course per inch equal to constant, which is called Kc again. Similar like the wave knitting, as well as in case of wells per inch also, Kw, that is the wells constant, is there. In warp knitting, all the yarn ends threaded through the guides of one guide bar knit the same constructions and are fed equally from the one beam only. So this is very important information that you have to understand. In warp knitting, all the yarn ends threaded through the guides of a one guide bar knit the same construction and are fed equally from the one beam only. So basically, one separate beam is required for a separate guide bar. If a machine is having the two guide bars, so there should be two warp bar beam, and from a single warp beam, all threads are to be fed in a guide bar. Okay, in the guides which are present in a guide bar, because the guide bar is having a same movement, and the guides which are situated over that guide bar also follow the same movement. So all the guides which are there in a guide bar, they will need the same structure. Okay, and that's why the threads which are fed in the guides which are present in the same guide bar should be coming from a same beam. The yarn consumption of each guide bar is called run in. This is in technical term run in, that is the yarn consumption of each guide bar, run in, and is measured as the length of each yarn knitted into the fabric during 480 knitting cycle. So run in is the amount of length of the yarn which is knitted by a guide bar during 480 knitting cycle. A working cycle of 480 knitted course is called rack. So this 480 knitting cycles, in an every knitting cycle on course is produced. So a working cycle of 480 knitted course is called as rack. So a longer run in per rack means run in per 480 knitting cycle. When this value will be higher, larger, so longer run in back produce a slacker fabric. Okay, where slacker fabric with big loops, while a shorter run-in per rack produces small and tight loop. Okay, you can imagine when there will be the longer run-in per rack, that means the longer length yarn is required for knitting 480 course of a knitted structure. So that means a high amount of yarn is there in 480 courses in a fabric, so all the loops will be longer. If the shorter length of yarn is consumed for preparation of the 480 courses in a knitted structure, then all the loops will be shorter. Okay, so longer run-in per rack produces slacker fabric with bigger loops, while the shorter run-in per rack produce small and tight loop. Run-in per rack should always be recorded when a new fabric is produced. Okay, when a new fabric is produced, then always you need to record the run-in per rack. So that will give you the information about the yarn consumption for the production of a particular length of the fabric. The run-in per rack may vary from guide bar to guide bar. Okay, so because the guide bars, all the guide bar may have the different motion, different movement. Okay, so that's why the run-in per rack may vary from guide bar to guide bar. So you need to calculate the run-in per rack for each individual guide bar. The relative amount of yarn fed from each beam is also very important. Okay, because that will give you the information how much amount of length is required uh, for completion of a fabric. Otherwise, there will be the beam fall of one beam earlier, and the amount of length which will be remaining in the other beam, that will be that will be a wastage. Okay, so that calculation is very important. You should have the beamfall time similar or simultaneously with all the beams which will be there in the warp knitting machines, and it is required, and uh, it is necessary actually for minimizing the wastage. So for that you need to have the knowledge of running per rack for all guide bars. The relationship is called run-in ratio. Okay, the run-in per rack of all guide bars is called run-in ratio, and the same is different from different fabric constructions and qualities. So a typical 2-bar machine, the run-in ratio for front bar is to back bar is in the range from 1.19 to 1.47. Okay, so run-in ratio of the front bar is 1.19 and back bar is 1, and run-in ratio of front bar is 1.47 and back bar is 1. So this is the range basically in case of typical 2-bar machine, that is the run-in ratio is from 1.19 to 1.47. So from this value it can be stated that the loop produced by front bar machine is bigger than the loop produced by the back guide bar. Okay, so loop which is produced in the front guide bar is bigger because the value 1.19 is bigger than the 1. Okay, and in the back guide bar, the run-in ratio, the value of the run-in ratio is 1, which is lower in comparison to 1.19. So that means the front guide bar here is producing bigger loop than that of the back guide bar. Yarn to fabric ratio, another important definition, that is equal to run-in per rack multiplied with course per unit length divided by 480. What does it represent? The ratio between the length of the yarn consumed by the knitting machine and the length of the fabric each produced. Okay, this is the ratio between the length of the yarn consumed by the knitting machine and the length of the fabric which is produced. Okay, so that means from this formula you can be able to calculate the amount of yarn or the length of the yarn is required for producing a particular length of the fabric. So let's understand this by some numerical example. When knitting a fabric of 20 course per centimeter and run-in per rack of 240 centimeter, then yarn to fabric ratio will be equal to 240 multiplied with course per unit length, that is 20, divided by 480 equal to 10. So that represents the 10 centimeter of work is needed for knitting 1 centimeter of fabric. Okay, so for manufacturing a particular length of the fabric, how much yarn is required, so that you can be able to calculate if you know the yarn to fabric ratio. Okay, now come to the tightness factor of the warp knitted fabric. For a machine with a single guide bar, tightness factor will be equal to under root x divided by L, the same formula as of web knitted structure, where L is the loop length in millimeter and text is the yarn linear density. The tightness factor for a 2 guide bar machine will be equal to under root text F divided by LF and under root text B divided by LB, where F and B refer to the front and back guide bars. Okay, because the machine is having the 2 guide bars and the 2 guide bars may have different yarn counts and different loop length, where L is the stitch length or loop length equal to run in per rack divided by 480. So loop length you have to calculate with this formula, run in per rack divided by 480. Run in per rack may be different from front and back guide bar. Okay, so that value you need to calculate, and you want to feed here in this formula to calculate the tightness factor of the overall knitted fabric. Okay, so it is measured in millimeter. So running per rack divided by 480, that will be measured in millimeter. Then this equation will be justified. For most commercial 2 guide bar full set fabric, the value of tightness factor is in the range of 1.1 to 2, while the mean tightness factor value is 1.5. So this is the typical value of the tightness factor of commercial warp knitted structure. So if your value is coming within this range, then your answer is correct. Otherwise, your answer not correct. So you can now assume or imagine the value. Okay, so that's all about the chapter of warp knitted structure. I think this will be helpful for you to understand the warp knitting technology, machines, various aspects and various knitting elements, their mechanism of knitting action. Okay, now I want to show one video that is also available in YouTube. Okay, where you can see how the warp knitting has been done. So you can see this video. Okay, here again this is the upward movement of the needle, then this is the overlapping, okay, by the guide bar, the downward movement of the needle. Okay, now casting off, then again needle is traversing up, then this will be the overlap by the guide, then the pressure will close the hook so that the casting off occur, then there will be the forward movement of the sinker. So these are the knitting elements, or knitting elements are present. In case of Tricoordinating machine, you can see how the knitting elements are acting to produce the loop. Okay, so all this mechanism has been already discussed. So I think this will be helpful for you. You can also see some such type of videos available in YouTube. Thank you. Happy learning.